So from this perspective, and it's just one of the demonstrations where modulo can be extremely useful, it's extremely important operator, very, very important operator in many different manipulations. Even sometimes when you're manipulating dates, it can be extremely useful when you're manipulating dates. And interesting, has some really interesting properties. Moving on, order of precedence is such that, for example, I knew when putting this together, I knew that this expression, result 9 divided by 2, will be executed before the result of it is compared to 1. How did I know? I just remembered that Java programming language comes with the order of precedence for its operators. And in that sense, the order of precedence for this modulo operator is higher than this comparison operator. By the way, comparison operator is not a single equal sign, but a double equal sign. And what's important about it is that it would be a mistake to put a space in between. That doesn't work. You must string them together, two double equal signs. So anyway, the precedence of this operator, comparison, is lower. That's why I didn't have to put the parentheses around this expression. But there's nothing wrong to actually put them explicitly, because sometimes it clarifies the expression and makes it easier to interpret by a human, right? So it's never a wrong decision to parenthesize an expression, a complicated expression, to parenthesize it to make it look like, clarified, basically, clarifying the intent of the programmer. So we can search on the web for the operator of, we could try something like this. If we go to Google and simply type Java operator precedence chart, that would be a great way to search. Operator precedence introduction. I guess this is an edu side. Let's try this chart right here, hopefully. So this is the way it sort of goes. It tells you, okay, so these are all the operators in the Java programming language, and you can see that you can read their descriptions of what they are. So far, we were looking at this test for equality. We were looking at perhaps addition and subtraction, and also multiplication, which is right here. The levels of precedence are specified here, and typically the precedence charts are constructed in such a way that something on top of this chart has the highest level of precedence. So therefore, multiplication right here is higher precedence than addition or subtraction, which have the same level of precedence. Just to let you know that's what's going on. There's also another part here, which is the associativity of the operator, and I guess I'm not going to discuss it right now, but this is an explanation or a rule to tell a programmer what this operator is expecting to find on the left-hand side or the right-hand side or both sides. For example, this associativity of the operator is such that, for instance, you know how I can say, well, I guess this is not a good example with invoice total, but if somehow it was a negative number, right? Okay, not a good example. Invoice total should never be a negative number, but still, right? And it's not even supposed to be an integer, so this is really completely off the charts, but still, right? So if this is a negative number, I know I can do this by placing a minus sign in front of my number. Okay, but could I do this, placing the negative number after the 19? No, because this negative sign, which is an unary operator, is is actually, if we look at this chart, just to be very specific, unary minus actually has associativity right to left, which means that uh, right to left means that here's the the minus sign, and it says to be usable I need to be interpreted right to left, which means that 19 needs to come on this side of me, on the right side of me. Then I'm okay. I am a valid expression now. But if I am here, there is really like semicolon on the right hand side, which is not a valid expression, and so this doesn't work. So this is what the operator associativity is. So it's basically putting operators in the right place with respect to the operator's operands, okay, which are the values that the operator is trying to manipulate. So sometimes you get to you get to construct more complex expressions, and they really don't work as you expect. In that case, sometimes you need to look up associativity of your operators and kind of start thinking maybe you misplaced some of the operators. I can't really think of a better example right now for our Java class. But at the same time, if you start learning C++ programming, then you will find out that in C++ operators can be overloaded by the programmer, and there the associativity of the operator becomes your day of life, because your way of life, because you really need to pay attention to the associativity, because the way you program those things. So too much time again spent on less important topics. But question, yes?
Question, is minus open paren minus closed paren 5 a valid Java expression?
Is this a valid expression right here, using parentheses in front of another sub-expression?
No, using parentheses to enclose an operator.
Oh yes, of course. Like this, to enclose just a single operator?
Yeah, but how about putting another operator before the first one?
Just like this?
So no, so it's minus open paren.
Minus 19.
Yeah.
Completely legal.
Illegal.
Legal. Becomes valid.
Valid.
Valid. So this is just a plus. Minus means plus. We flip the sign two times, and we end up having a positive number. So you can also do it without parentheses, like this. But you have to use space, because minus is actually a decrement operator, so it's not two minuses in a row. So it can be done like this, which is really confusing, but completely legal and valid, right? So it just means this, right? But yes, they can be once used, the operators can be applied, and there is no restriction. As long as the expression is legal, the operators can be used. No restrictions exist on that part. So let's see if we can talk a little bit more about operator precedence. So this is much more practical example of the importance of the operator precedence. For example, if I say an integer count equals this expression right here, 2 plus 3 times 4, right, which is from the slide. What happens is that Java compiler examines these expressions, finds out that there's intent to add and multiply, and then the question is, in what order should this be done? What happens is that to determine in what order everything is done, the operator precedence is applied. The rules of the operator precedence is applied in the following manner. So it's not like, okay, we have 2 plus 3 multiplied by 4. Instead, what happens is that the compiler sees that there's a multiplication, it means that it will have higher precedence. It will be grouped internally, just like this, as if the parentheses were used explicitly by the program. So the multiplication will take place first, and then 2 will be added to the result of that. So the result should be 12 plus 2, 14. So if it's not what we wanted, then we have to use the parentheses explicitly and say, oh, okay, we want to parenthesize this and make sure we first we do the addition and then we do the multiplication. Okay. So in this case, if that's what you want, right? And of course, this should be some variable. This is like another variable that you have, and this could be, some, you know, factoring that you take like this. So anyway, if you need the addition to take place first, you have to parenthesize it obviously before the multiplication should happen, because this is your intent. Otherwise, by default, operator precedence rules apply, and in case if no parentheses are used, of course, then this will be computed first. So the awareness of operator precedence is very important. However, grouping, which is using parentheses around sub-expressions, is given to the programmer so that it can clarify the complex expression very nicely. And so there's basically nothing wrong, and no one should be ever penalized for actually doing this, because the argument goes, this makes this expression clear, more clear. After all, there is some abstraction used here. For example, instead of mathematical ways to express multiplication, sometimes with a dot, sometimes without the dot, we use an asterisk, a little star in the midst of it. So, after all, this may as well clarify it for some people. So there's nothing wrong with clarifying it like this.